Okay, great. We're on to the third and final section. We're going to teach you about linear models. Might not sound the sexiest thing when you've got deep neural networks or Gaussian processes, but trust me, these are really the foundation of machine learning and a really good way to get the building blocks so you can understand those more complicated models that we're going to look at in the other sections. Okay, so as with the other section overviews, just going to fly through the general topics that we'll be looking at in this section. So, yeah, sorry for the meme, but let's learn regression, right? Yeah. Okay, so it's all about building general linear models. Linear models is more than straight lines. Often people think linear models, straight line, can be straight lines, but we'll get on to why it's more than a straight line. And actually, the meme is not quite right. It can be more than regression. So we're going to look at classification problems as well. Okay, so running through this section quickly, we're going to first look at kind of the fundamentals of machine learning in the sense that it's about function approximation or curve fitting. So we're going to kind of recap on probably things you remember from school around curve fitting. We're then going to extend that from, we're going to fit a straight line to start with, but then we're going to talk about general linear models. So how do we fit more general types of models? And actually, in general linear models, these can be quite complicated models like polynomials, they include sine waves, they can include all sorts of features that you might want to include in that model. So when we start including more and more features or using less features, the topics of underfitting and overfitting, which are central to the idea of generalization in machine learning models, come to the front, right? And then we're going to particularly talk about, in machine learning, when we have highly parameterized models, really overfitting is the challenge. And then we're going to talk about techniques that we can use to help us prevent overfitting. In particular, we're going to focus on regularization. It's not that you need to implement it yourself. Most of the packages that I'm going to show will do it automatically, but there are some key choices that you have to make when you use it, and you need to know what it's doing under the hood rather than how you do it so that you can use those tools effectively. We're also going to talk about relationships in data, so understanding what we mean by correlations, and then also nonlinear correlations, so the case where maybe the relationship between a variable is more complicated than a straight line. So we're going to talk about something called predictive power score, which is a really useful tool about how well one variable can predict another. A bit more complicated than standard correlations, but really useful tool to know about. And then the two final topics, in linear models, we can take a view on the unsupervised learning component and talk about principal component analysis. So this is a linearized way in which we can extract the important linearly independent features from our data set. Don't worry about the terms yet, we'll get onto that, but a really widely used tool at the early stages of exploring your data in data science and machine learning. It's sort of a joke, once you get a data set, have you done PCA, principal component analysis on it? It's normally one of the first things you do on data, so really important you know about it. Then the final part is talking about logistic regression. Logistic regression is a generalization of a linear model, which you're then using for a classification problem. So really important that you can extend these kind of regression models to classification. Once you've done this, this will be the end of this course, but this will put you in really good foundations to look at other types of more complicated deep learning models later in the course. So a neural network is really can be seen as a composition of lots of linear models together. Know this gets you in good foundations for the rest of your journey through machine learning. All right, let's do it.